Welcome back to Mr. Hassan's Maths channel. I'm now answering a question from a Mechanics M1 paper from the International A-Level Edexcel exam. This is from June 2018. It's question number 4. This is the IAL, not the GCE paper. At that point, there were also GCE papers. This is the IAL paper. And it says a rough plane is inclined at an angle of alpha to the horizontal where tan alpha equals 3/4. A particle of mass 2 kilograms is projected with speed 6 meters per second from a point on the plane up a line of greatest slope of the plane. The coefficient of friction between the plane and the particle is 0.25. So part A says find the magnitude of the frictional force acting on the particle as it moves up the plane. Okay, so now here they don't have a diagram. No diagram to be seen anywhere. And many students, they start freaking out when they don't see the diagram because, they're a bit not very confident in drawing these diagrams. That's why in my classes sometimes I actually remove the diagrams for my examples when I give them a question, even though the diagram's there, so you can practice drawing the diagrams from the words. So you have a plane that is inclined to the horizontal at an angle of alpha. Okay, so we don't know what the angle is, but we know the tangent of the angle, because there's a few points that we're going to go through about that. So this is the angle, which is alpha, that's inclined. This is the plane. The tangent of alpha is 3/4, as they told us. Now there's a particle of mass 2 kilograms is projected with speed 6 meters per second from a point O on the plane. So let's say this is the point O, and let's say this is the particle. It starts from there. It's a particle of mass 2 kilograms and is projected with speed. Initial speed is 6 meters per second. Okay, it's saying that the coefficient of friction between the particle and the plane is 0.25. So it's a rough plane. And what all this stuff about up the line of greatest slope, what does that mean? Well, if you have a plane, if supposing we're looking at this ramp from this angle here, maybe at a slight angle, we could say. Okay, so you're looking, what you'll see in front of you is something that's kind of like this. It's going upwards. That's the plane. Okay, so what it means is basically this object is not going at an angle like this or like that. It's going up the shortest distance up the plane. It's going up like that. Okay, the line of greatest slope of the plane. So it's going up that line, not going at some sort of angle. That's what it means by this statement here. A lot of students don't really understand what it means. It doesn't really affect the question. That's obviously how we're going to deal with it. But just for your information, that's what it means. So this is the point O, and that's the object. I'll put that also on the side slightly. Now, what are the forces acting on this object? It's projected up the plane. It's being projected. There's no force now pushing it anymore. It's given this initial push, and now it's not being pushed anymore. So the only forces acting on it, once it's been initially pushed, are its weight, which acts always vertically downwards. Let me just make that a bit thinner. Okay, and also it's the reaction force, because it's in touch with the surface. What's going on here? It's in touch with the surface, so you have the reaction force, which is always perpendicular to the surface itself. And because it's a rough plane, there's frictional force, which is opposing the motion. It's going up the plane, so the frictional force must be going down the plane. It's moving, so we know that the maximum force of friction has been reached. So you have the reaction force, which we don't know. We have the weight, which is 2g newtons. All right, so mass times the weight by times acceleration due to gravity. So it's mg, 2g. And we have F max. Now, F max has been achieved because it's moving. All right, so the friction has got to its highest possible amount, and it cannot increase on that amount, okay, because this thing is moving. So the F max is equal to, as we know, mu r, and we know mu is equal to 0.25, the coefficient of friction. All right, so we want to find the magnitude of the frictional force acting on the particle. So that's basically, we want to find F max. So to find F max, we need to know what R is. So R is equal to, now what we'll do to find R, we're going to resolve the forces perpendicular to the plane, because R is acting perpendicular to the plane. So the weight that's acting vertically downwards must be resolved in a direction which is perpendicular to the plane. Okay, so I'm going to resolve the weight perpendicular to the plane, which is in this direction. Now this is the angle alpha. Now why is this angle alpha? A lot of students just write down, they say it's alpha. We don't know why, but we know it's alpha. Okay. I like for students to understand why it's alpha. The reason why it's alpha is because we have this triangle over here, this whole triangle over here, and you have this small triangle over here. And these two triangles are similar triangles. So if I just take a little few seconds to draw something like this. So I've got this big triangle here. Okay. And this big triangle, which I will just, oops, I don't need that. Okay, so I will group those together. Okay, so I've got this, no, what have I done? 1 second. Okay, I don't need that part of it. I just need these three. One, nope, not that. I need this. What am I doing? Give me a second. Okay, sorry about that. Yes, so basically we have this triangle over here. Okay, and we have, that's the alpha there, sorry. And we have this triangle over here. Okay, so basically I know this angle is alpha, right? And I know that this is 90 degrees up here, for sure. That's 90 degrees. And I know this angle is 90 degrees in this triangle. And the other thing I know is basically that this angle is the same in both triangles, because this triangle is over here, right? So the angle in this corner over here is the same as the angle over there. So those two angles are both the same. We don't know what they are, but it doesn't matter. I know that this angle is the same as that angle. Two of the angles are the same in both triangles, so they are similar triangles. That means the third angle must be the same as well. So that's the reason why this is alpha, right? So there's a little, way that I like people to understand what's going on. So that's the reason why we call this alpha. All right. Now the next thing we're going to do is we're going to resolve this force, this 2g newtons, in the direction which is perpendicular to the plane. So basically what we have to do is you have to resolve it in this direction. So in fact, if I get back this triangle here, okay, that might help us to understand why. So basically we got to resolve in this direction here. Now, when I resolve in this direction, in fact, I'm not going to use this triangle. I'm going to use a triangle such that this is now parallel and perpendicular to the plane. Okay, so this is the parallel direction. This is sorry, perpendicular to the plane. This is parallel to the plane. So this side here, so this is not really any good for us, to be honest, to look at this one. That's just for finding that angle is alpha. But now this side is like the adjacent side compared to this. If this is the right angle, this is the angle. Okay, this force is resolved in this direction. This is like the adjacent side, so it's going to be cosine. Another way you can think about it is if you have to resolve the force in such a way that you have to go into the angle given, you use cosine. Okay, so here we're going to write this as 2g times cosine of alpha. So that's r. And we know we can work out what the cosine of alpha is because we know the tangent of alpha is 3/4. And that's another important point here, which many students don't appreciate. We know that the tangent of alpha equals 3/4. Well, what does that mean? Well, if we have a triangle, which is right angled, and this is alpha, the tangent of alpha means the opposite is 3 and the adjacent is 4, which means the hypotenuse must be, by Pythagoras, 5. 3 squared plus 4 squared, that gives you 25. Square root gives you 5. So from that, we can work out the exact value of the sine of alpha and the cosine of alpha, which we might need in this question. So we can see the sine of alpha is the opposite over the hypotenuse, which is 3/5. And the cosine of alpha is adjacent over the hypotenuse, which is 4/5. So we don't have to actually find this angle and then give like some sort of rounded value. We can give an exact value. For example, I want the cosine of alpha 4/5. I can use 4/5 or 0.8. So I can say r is equal to 2 times g times 4/5. Okay, so I end up with 8 over 5g. Now, that's r. That's the value of r. So therefore, the friction, which is its maximum value, is mu, which is 0.25. I'll write that as a quarter times 8 over 5g newtons. So F max is equal to, that cancels with that, 2/5 g newtons. Okay, you can say 2/5 g newtons, you can say 2g over 5 newtons. I'll write it like that, 2g over 5 newtons. Okay, that is the value of the friction acting. Now, you can leave your answer in terms of g. That's perfectly good in M1. You could also write your answer, because we use g in a calculation, we can write it to 2SF. That's, if you're going to round it, if you're going to use g as 9.8, then technically the best thing for you to do is for you to leave it in terms of 2SF. Okay, however, what would be the safest thing to do if you're going to use g as 9.8 would be to write it to 3SF, because sometimes what happens is you might not use g. If you don't use g, then you have to write to 3SF. If you use g, you have a choice. So 2 times 9.8 over 5, which gives us 3.92. So you can write this as 3.9, or you can write it as 3.92 newtons. Any of those three answers would be acceptable. Now, I like to leave things in terms of g when I can. Right, so I would personally write it like this for this answer, unless they ask me to round it. And if I was going to use g as 9.8, then I would write my answer in the exam like this, because, as I said, they accept 2SF or 3SF. That's really the correct thing to do. However, they accept 3SF, and if you had a question where you didn't use g, you have to write it to 3SF. You can't write it to 2SF. Right, so just to be on the safe side, this will be accepted for every type of answer, unless they told you to round it to something else. Right, so in terms of G, 3SF, 2SF, all of them are acceptable answers. That's for part A. Now for it says part B, the particle comes to instantaneous rest at the point A. Find the distance O to A. So it goes up to A, and at that point its speed is 0 meters per second. And we want to find the distance between O and A. That's what we want to find. We want to find that distance. Okay, that's what we're trying to find. All right, I'll call that S. Now, so for us to deal with this, we need to know what the acceleration is. It's going to be, of course, decelerating, because the only force acting on it is the friction now, and the component of the weight down. So what we're going to do now is we're going to resolve the force also parallel to the plane, but down the plane. Okay, of course, let me just change the color of that, make it red as well. All right, so we're going to resolve the weight also down the plane. So this is going to be, the component of this was 2g cosine alpha. So this is going to be 2g going away from the angle, looking at the side that's opposite the angle. So it's 2g sine of alpha. All right, so the force is acting upon this object. So we can say the resultant force is equal to the mass times the acceleration. So the resultant force, I mean, it's going upwards, so I'm going to take up as positive. There's no force acting upwards. Okay, the only force is acting downwards, so it's minus 2g sine alpha minus F max, okay, which we know already now. And we know that's equal to its mass times acceleration, which is 2 times the acceleration A. That's what we need to find for us to proceed with this question. So I know that sine of alpha is 3/5. So I have minus 2g times 3/5 minus F max, which I'll put in terms of g. That's 2g over 5, and that's equal to 2a. So this gives us minus 6g over 5 minus 2g over 5 equals 2a. So we have minus 8g over 5 equals 2a. So a is therefore, if you divide by 2, minus 4 over 5g. So that's the acceleration. So now we can use suvat, because we have constant acceleration, deceleration of minus 4 over 5g. S is what we have to find. U is the initial speed it was given, which is 6 meters per second at O. V is the speed at which it reaches its instantaneous rest, which is going to be 0. Okay, that's 0 meters per second. And time, well, we don't need to know the time. We have to deal with S, U, V, and A. So we can use the formula V squared equals U squared plus 2AS. And we have all of these except for S, which we have to find. So this is 0. U is 6, so this is 6 squared plus 2 times the acceleration, which is minus 4 over 5g times S. So you have 0 equals 36, and that's minus 8 over 5g times S. So when you rearrange that, you have 8 over 5g times S equals 36. So S is equal to, we got 36 times 5 over 8g. 36 over 5 over 8g, and that's going to give me S, which I'll then round to a certain number of decimal places. So 36 times 5 divided by 8 times, and I'll use 9.8 now. Okay, and that gives me 2.2959. 2.2, what was it? 2.2959, it goes on. So we can write our answer to 2SF, which is 2.3, or we can write the answer to 2SF, which is 2.30. Okay, it's meters. We're talking about meters per second. Yes, meters per second, so it's meters. So the answer, I would write it like this, but you can write it to 2SF as well. It's fine. And there we have the answer. We use G as 9.8. Okay, G equals 9.8, and we got this answer. All right, so there's the answer to part B of this question. All right, so we found the distance OA. So S is the distance OA. You could state that here. Okay, S is equal to OA. So that means OA is equal to 2.30 meters, just to make it very clear. All right, that's part B. Now for part C of the question. Is there a part C? I think there is. Yes. The particle now moves down the plane from A. Find the speed of P as it passes through O. Okay, so now basically what's happened is you have this particle that has gone up to A. So it's gone from O to A. All right, so it's gone up. Now what's happened now? It's reached A. It's come to rest here. So now we can say its speed here is 0 meters per second. Okay. And we want to find its speed when it reaches O on the way down. Now it's moving downwards. Okay. Now, when it starts moving down, the difference between this situation and the last situation, the weight is still the same. The weight is still acting vertically downwards. Okay. You still have a component of the weight in this direction here. Second, let me change the color. In this direction here. And you also have a component of the weight going down the plane as well. Okay. The difference now is we also have the reaction force, which is also acting perpendicular to the plane. Okay, that will be this the same as before. The reaction force would be the same. Okay, that's still R. And this is still 2G. This is still alpha. This is still alpha. Okay, so this is 2G cosine alpha, as we said. This is 2G sine alpha. All right. The difference now is because it's moving down the plane now, what's going to happen is the friction is going to oppose that motion and it's going to be acting up the plane. So F max is now, it's going to be its maximum value, but it's going to be moving, it's going to be acting up the plane. So now when we look at the resultant force, we're going to take down as positive as it's moving down. Okay, so the acceleration is in this direction now. Okay, and we can see that the resultant force is 2G sine alpha minus F max, which is equal to mass times acceleration, which is 2 times A. All right, so now what we need to do is to find the acceleration in this situation. So we know already this is 2G, we know the sine of alpha, All of that stuff we already know from before. 2g sine alpha, 2g times 3/5, which is 6g over 5, but that's going to be positive now. So 2g times 3/5 minus, and now F max, okay, is 2g over 5 newtons. Okay, so F max is 2g, still going to be 2g over 5, that's not going to change. But now this is going to be negative because we're going down and it's going to be going up, so it's in the opposite direction, so it's 2g over 5. So now this was negative before because we were taking up as positive, and this was negative as well because we were taking up as positive. Now we're taking down as positive because it's moving down the plane. Always take the direction which something's moving as a positive direction. So in this case, I'm taking down as positive as this is moving down and going back down towards O. So I'm taking 2g sine theta alpha, sorry, as positive, and F max as negative because that's acting opposing this motion, and that's equal to 2 times A. So now I have 6g over 5 minus 2g over 5, which is 4g over 5, equals 2A. So we can say now in this case, A is equal to, if you divide by 2, 2g over 5 meters per second squared. So now the situation has, of course, a different acceleration. We know that distance, although I don't think we need it. Okay, we know that distance already. We found it in the last part of the question, which was 2.2959, if in case we need it slightly more accurately. 2.2959. Okay, U is 0, it's initial speed. V is what we have to find. The acceleration is 2g over 5. In fact, so v squared equals u squared plus 2as. Yes, I think we will need this value of s that we found. So we can now find what v is. We can say v squared equals u squared plus 2as. So I'm going to take this as the value that included g here before, which is was 36 times 5 over 8g. All right, that's a 180 over 8. Let's see, 36 times 5 over 8. 36 times 5 over 8. That gives us 45 over 2g. So I'll take the s as 45 over 2g. Okay, that's 45 over 2g, just for the sake of keeping things more accurate. So we have v squared equals u squared, which is 0 squared, plus 2 times a, which is 2g over 5, times s, which is 45 over 2g. See what happens here when you keep things in terms of g. Here you'll see that this 2g cancels with this 2g, and you have the 5 cancels with the 45, gives you 9. So you end up with v squared equals 18. So v is equal to the square root of 18, which is equal to that's going to be root 9, that's going to be 3 root 2. Okay, so the square root of 18, which we will round it to 3SF. So we have the square root of 18, which gives us 3 root 2, which is 4.2426. So that's, sorry, v equals 4.2426. So we can write our answer as 4.2, or we can write it as 4.24. So I'll choose the version which is to 3SF. So 4.24, don't forget to put the unit. So 4.24 meters per second is the answer. You could write 4.2 meters per second if you wanted to. Both of those are fine. So that concludes this answer for question number 4. Other questions from this paper. Now, the important thing, as I mentioned to you, the difference between Part B and Part C. In Part B, it was moving up, friction was acting down. Everything else was the same. In Part C, the thing is moving down now, and therefore the friction acts up. Right? The reaction force is the same, the components of the weights are the same. The difference is the direction of the frictional force, which makes a change, of course, to the question. So that's important for you to understand about friction. So other questions from this particular paper can be found in the playlist that will appear over here. The playlist that appears over here will be about the topic of dynamics involving friction, and you can subscribe to the channel by clicking on this link. This video up here will tell you how to navigate the channel so that you can find things quickly that you might want to benefit from. Thank you for watching, and see you soon.